This question is from the GATE Physics paper 2021. There is a MCQ type question having 1 mark, and the question was asked from the topic solid state physics. The question is, choose the correct statement from the following. Option A, silicon is a direct bandgap semiconductor. Option B, conductivity of metals decreases with increasing temperature. Option C, conductivity of semiconductors decreases with increasing temperature. And the last option, option D, gallium arsenide is an indirect bandgap semiconductor. So here 4 options are given. We have to choose the correct statement among these. So we'll verify all the options one by one, and we'll check which option is correct among these. Let us see the solution part now. The first option, option A, is false because silicon is an indirect bandgap semiconductor. Now this is a typical EK diagram of an indirect bandgap semiconductor. The band gap is defined as the difference between the energy at the conduction band edge and the energy at the valence band edge. Now, in order to have an electronic transition from valence band to conduction band, the electron has to gain the energy equals to band gap of this system, that is EC minus EV. But this is not only the case, because in order to have the transition, electron has to change its momentum to reach the conduction band edge. That is the momentum difference between this conduction band edge point and the valence band edge point. Now this extra momentum to the electron is provided by the phonon, which is basically the quanta of the lattice vibration of the semiconductor. So in the indirect semiconductor, the electron rising from valence band to conduction band will change its energy as well the momentum. The second option, option B, is true, which is conductivity of metals decreases with increasing temperature. From the root model, we know conductivity of a metal is given by N E squared tau by M, where N is the carrier number density, E is the electronic charge, tau is the relaxation time or mean collision time, and M is mass of electron. Now with change of temperature, the carrier number density N doesn't change much. Effectively, it will remain unchanged. But the collision time or relaxation time decreases with increasing temperature because this scattering probability between the electron and ion core increases. So your option B is correct. Now the option C is false because conductivity of semiconductors increases with increasing temperature. We know as the temperature increases, more and more electrons will be excited to conduction band from valence band, and it results in the number density of electrons and holes will increase in conduction band and valence band respectively. Hence, the conductivity of the semiconductor will increase as the temperature increases. Your option D is false because gallium arsenide is a direct bandgap semiconductor. If we see the EK diagram for the direct bandgap semiconductor, the edge of the conduction band and the edge of the valence band lies at the same K point. So, in order to have a transition, electronic transition from valence band to conduction band, the electron needs only the energy which is equal to the band gap of the semiconductor. Electron doesn't need any momentum change because the edge of the conduction band and the edge of the valence band lies at the same K point. So in direct bandgap semiconductor, the electron rising from valence band to conduction band will only change its energy. So we checked all the statements one by one thoroughly, and we found that only the options B, that is conductivity of metals decreases with increase in temperature, is the correct one for this question.